Picture a perfect grapefruit-sized sphere sitting right in front of you. Honestly, it doesn't look menacing at all. Yet, this incredibly dense little orb holds a terrifying dual potential. It has the energy to push human ingenuity all the way into interstellar space, or the raw, unfiltered power to level a major city in a fraction of a second. Welcome to today's Explainer, where we're going to pull back the curtain on the ultimate forbidden alchemy, the meticulous, terrifying, and honestly awe-inspiring process of manufacturing plutonium.
Okay, let's dive into this. 0 grams. That is exactly how much plutonium exists naturally in the Earth's crust. Think about that for a second. Unlike uranium, which you can actually go out and mine from the ground, plutonium has to be entirely forged by human hands. It is one of the few truly artificial elements in existence. Every single ounce of it on this planet was systematically manufactured inside the blistering, radioactive core of a nuclear reactor.
And that brings us to the ultimate human paradox. Let's call it the just-in-case perspective. We literally went out of our way to invent the most terrifying, dangerous element known to science, and now we stockpile it in highly classified, heavily guarded global silos. Why? Well, just in case. We engineered a material entirely capable of ending civilization as a form of ultra-paranoid insurance. It's a fascinating, if entirely unsettling testament to human nature. But to really understand how we got here, we have to look at how this impossible element is actually born.
So the inciting incident of this whole story takes us back to 1941. Scientist Glenn Seaborg and his team at UC Berkeley were working with a cyclotron, which is basically a massive particle accelerator. They decided to take naturally occurring uranium-238 and just relentlessly bombard it with tiny subatomic particles called neutrons. Over a period of a few weeks, what they witnessed in that laboratory would go on to permanently alter the course of human history, for better and, without a doubt, for significantly worse.
And this brilliantly illustrates what we call nuclear transmutation. You see, inside the reactor core, the uranium atoms don't just split apart. They actually absorb those incoming neutrons and gradually, atom by atom, mutate into something entirely new, plutonium-239. It is honestly like dark magic. It's completely invisible to the naked eye, yet fundamentally capable of reshaping the entire geopolitical landscape of the world.
Just to put the sheer mind-boggling power of this transmutation into perspective, consider this. Just 1 single gram of this new plutonium releases more kinetic energy than burning several tons of coal or oil. The energy density is just completely off the charts. But of course, harnessing that kind of power means dancing right on the razor's edge of a catastrophe.
Because in a nuclear reactor, there is absolutely zero margin for error. This conversion process is anything but routine. Any deviation, no matter how small, could trigger a catastrophic nuclear incident. That is exactly why this entire transmutation process is monitored around the clock. We are talking about automated sensors everywhere, massive steel shielding, and highly specialized personnel whose entire job is to never, ever take their eyes off that reactor core.
Once that relentless neutron bombardment is finally complete, the uranium fuel rods are extracted, and at this stage, they are quite literally glowing. Direct human contact would be instantly fatal. So using sophisticated remote-controlled systems, these incredibly volatile rods are plunged into enormous cooling pools. And these aren't your average swimming pools. We're talking reinforced concrete walls over 6 feet thick, with the rods submerged under 16 feet of ultra-pure water, where they will just sit and cool for several months.
Now, what's really interesting about this is a phenomenon called Cherenkov radiation. As the irradiated material slowly releases its accumulated radiation to become stable enough to handle, the water around it actually glows with this faint electric blue light. It is widely considered one of the most hauntingly beautiful sights in all of nuclear science. But hey, don't let the beauty fool you. It's literally a visual marker of intense, lethal energy slowly burning itself out.
Only when every single parameter is fully stabilized is extraction from that blue pool authorized. And ironically, that triggers the most dangerous stage of the entire process. The rods enter an automated cutting system where they're violently sliced into metallic fragments. Then, these pieces are dropped straight into concentrated nitric acid at temperatures well over 212 degrees Fahrenheit. What results is a thick, intensely radioactive liquid. It is, without exaggeration, the most dangerous solution on Earth.
That boiling, lethal liquid is this chaotic cocktail of uranium, plutonium, and highly unstable radioactive waste products. So how do you get the plutonium out? Well, scientists rely on one of the most sophisticated chemical processes ever engineered, known as Purex. By introducing highly specialized chemical solvents into the mix, they can selectively bind to the plutonium atoms. It acts almost like a chemical magnet, pulling the plutonium out of the mixture, one individual atom at a time, leaving all that radioactive waste behind.
Think of the Purex process as panning for gold in a river of toxic waste. But the gold that emerges from this process looks absolutely nothing like the glowing green ooze you see in movies and comic books. It's actually a dense, yellowish liquid, and it is so intensely radioactive that just a few seconds of direct skin contact with this fluid would be completely fatal.
So the crucial point here is that in this liquid state, plutonium is incredibly unstable. Even minimal exposure to the ambient air could trigger an immediate, localized nuclear emergency. You simply cannot store it or transport it safely as a liquid. And that demands a rapid, highly controlled conversion into a solid, much more manageable form known as plutonium oxide.
Technicians actually refer to this next critical stage as the atomic bake. Inside hermetically sealed lead-lined laboratories, that lethal liquid is dried at extreme temperatures. As it condenses, it transforms into a dark powder that looks remarkably like volcanic ash. Once that powder is stabilized, massive industrial presses come down with immense force to compress the ash into small cylindrical metallic pellets. They're roughly the size of a coin. Dense, compact, and extraordinarily lethal, these pellets are the final finished form of human-made plutonium.
Let's move to how this builds into the most consequential fork in the road in all of modern science. Because once these little pellets are pressed, these identical coins of compressed energy can take one of three completely different paths, depending entirely on human decision-making: civilian power, deep space exploration, or military use.
If the plutonium is destined for the stars, it's formulated into a specific isotope, basically a slightly different atomic flavor, called plutonium-238. This is the ultimate fuel for deep space. Out where the sun's rays are just too weak to power solar panels, a generator containing a mere 10 pounds of this material can provide enough reliable electricity to run a spacecraft's instruments continuously for 15 years or more. It's incredible.
And here is the defining tension of our age: progress versus peril. On one hand, you have these breathtaking scientific triumphs. Plutonium has powered our most iconic missions: Voyager 1 crossing into interstellar space, Cassini diving through the rings of Saturn, and the Curiosity and Perseverance rovers actively exploring the dusty surface of Mars right now. But on the other hand, there is a deeply cynical reality. 9 nations around the globe secretly transport this exact same material in heavily armed convoys to serve as the active cores of nuclear warheads.
It is a really dark duality. Plutonium isn't just a physical material anymore. It has become a declaration of absolute power. It's the ultimate symbol of human control. Sitting quietly in those global power silos, it represents a sort of manufactured godhood, an element utterly capable of lighting up an entire planet with energy or completely erasing it from the map in a matter of seconds.
So, after seeing exactly what goes into forging this forbidden alchemy, where do you stand? Is plutonium an indispensable scientific achievement that pushes humanity into the stars? Or is it a catastrophic human mistake we can no longer control? It is the ultimate contradiction between exploration and destruction. Think about that the next time you look up at the night sky. Thanks for joining us on this explainer, and we'll catch you in the next one.